Alright, so in today's video, we will learn the distance formula and the idea behind that formula. Okay, so let's consider first these 2 points. So let's just say we have point A and B. Okay, and we want to know the distance between point A and B. Now in this case, that's easy because if we draw a horizontal line, we can count the number of units from A to B because it's, you can see those dotted lines. We can clearly see that AB is just 2 units. That's easy. Now we're dealing with points here that are aligned horizontally. Now let's consider these 2 points, and these 2 points are aligned vertically. Let's just say point C and point D. So if we want to know the distance between C and D, that's also easy, right? Because we can do this: 1, 2, 3, 4, 5, 6. So CD is just 6 units. Alright. So the problem is, not all lines are like that. Not all points are arranged horizontally or vertically. Sometimes they are arranged diagonally. So for example, let's name this as point E, for example, and then this is point F. Okay, so obviously, if we connect those 2 points using a solid straight line, that's diagonal. Okay, so how are we going to find the distance between E and F? Alright, let's try this method. Okay, so what I'm going to do is I will draw a horizontal line from point E to, let's just say, point O. Okay, and then from point F to point O, I'm going to connect those two. So what we have now is a right triangle. So EF represents the hypotenuse. Is that right? Okay. We know that EO, the length of that is easy to know, which is 3 units. And FO is equal to, that is correct, 4 units. So now we have this EF, which is the hypotenuse. And in order for us to find the length of that hypotenuse, what we will do is we will use yes, that is correct, the Pythagorean theorem. So we have a squared plus b squared equals c squared. Let's say that number 3 is our a and the 4 is our b, and then EF is our c, which is the hypotenuse, right? So a is 3, this means 3 squared. B is 4, that means 4 squared, so c squared. 3 squared is 9, 4 squared is 16. 16 plus 9 is equal to 25, so this is c squared. So square root of 25 is equal to 5. So there you go. That's our EF. Now, let's try to generalize everything, okay? So let's consider another point, this point for example, and then let's call this as point M. And then let's have this point all the way here, okay, N. Alright, so let's draw another right triangle. So obviously this is the hypotenuse, and then let's draw this. Let's name this as point P. There you go. So this time what I'm gonna do is, because we will generalize everything, I am going to consider the coordinates. Okay, so for point M, the coordinates of that are 2 and 1. Is that right? Okay. For point P, the coordinates of that are 4 and 1. Okay. So for point N, that would be 4 and 6. Now let's label the points. So 2 is x, so let's just say that's x1, and then since that's our x1, these are y1. And then for 4 here, this will be our x2, x sub 2, and this is our y sub 2. Okay. Okay, this 4 is obviously x2, right? The 1 here is obviously y1. Alright. Okay. If we want to know the distance of MP, we all know that that's 2, right? But That's the same as subtracting this. So if we want to know the distance of this base, that's just x sub 2. Okay, so this, I'm just gonna write it here. This is x sub 2 minus x sub 1. Is that right? Okay. Now if we want to know the distance between n and p, okay, n and p, this, we know that that's 5, right? So that's the same as y2 minus y1. See that? 6 minus 1. 6 is y2, 1 is y1. So that's the same as y2 minus y1. All right. So we have this, and then we have this. All right. Now let's just say that m and n, let's name this as d, the distance between those 2 points. Okay. And then I'm gonna apply the we will now apply the Pythagorean theorem. So that's a squared plus b squared equals c squared. So our a is the base, that's this, which is x squared minus, x1 minus x1, x2 minus x1 square, plus b, which is y2 minus y1 square, and then d square. Okay. But we want to know the distance specifically. So remember what we did here? You see that? So meaning we will take the square root of both sides. And there you go. That's our distance formula. So x2 minus x1 square plus y2 minus y1 square. That's our distance formula. And in order for us to find the distance between 2 points, now let's solve this now. x2 is 4 minus 2 plus y2 is 6 minus 1 square. All right, so this is 2 square, which is 4, and then 6 minus 1 is 5 square, which is 25. So 4 plus 25 is 29. So the distance between that, there's no, the square root of 29 is a decimal, so we keep it like that. So the distance between m and n is square root of 29.